Welcome back, everyone. My name is João Pedro. I'm a main engineer at Datamine South Africa, and I'm here with Hajar, also a Datamine engineer, and we are today to present the fourth section of our mine planning campaign webinars. Today we're gonna talk about sequence generation on NPV scheduler. As usual, if you have any questions, please type it down in our section here in the GoToWebinar. And by the end of the presentation, we're gonna reply them. Okay, let's start. Just a quick review. At the first webinar, Hajar taught you how to generate ultimate PIT using NPVS. So set a block model, apply economics parameters, and choose the best LG phases for ultimate PIT. At the second webinar, Terence taught you how to design a PIT using our Automax tool, how to add road and switchback, and also how to create surface. At the last webinar, I went through with you how to generate pushbacks on NPV. So we import the Terence design, we generate pushback, and then we export the block model for the pushback designs. Okay, so at this webinar, I'm gonna import the pushback designs. We're gonna set the sequence parameters, and then we're gonna export the model to OP. So some informations. As Hajar said, the production rate will be 1.2 million tons of ore per year. And then we have 12 years of life of mine. And it gives us almost 9 million tons of ore rock per year. We also gonna set the ramp-up factor. So at the first year, our production will be only half. The second year will be 3/4. And from the third year, we're gonna achieve our production. Okay, so now let's go to Studio P. Here, Terence gave us the speed. And from the last webinar, we have this block model legend by pushbacks. And as a result, I designed those pushbacks for this webinar. Okay. First of all, I want to say these pushbacks are not perfect. Okay. So as you can see, the block model from NPV is just a guide for the pushbacks, but even so, some shapes is not that good, and some benches has no way out. Okay, so but there's no problem. The NPV won't consider this, and also it's not our goal to make perfect pushbacks. So after we design the pushbacks, I need to save them, and then that I can go to NPV, right? NPV here, I'm using the same project as I used in the last webinar. That is the same project Hajar used. Okay, here we have our pushbacks. So now our first step is import those surfaces. So here in optimization section, you can go to Datamine surface. I need to tell you guys that it's very important to import the pushbacks using in order. Okay, so from the smaller one to the biggest one. Okay, so here we select our triangle file, then our point file, Here we not use any of these fields. Okay, and now you need to give it a name. So here we're not gonna give the name like pushback 1. We need to give a name that will group all the pushbacks. For instance, webinar 4 pushbacks. So this is the name I choose as well here. Okay, so the first surface I save, and the next one I just click in append to file, and then I select the name that I have. I already did that. Okay, here in webinar 4 pushback 2. Okay, so I'm not gonna do this again. So we can visualize the result. Other surface, webinar pushback 2. Okay, so here is my first pushback, my second one, the third, and the last. Just to you guys, here is my first try. I import not in order, so I import first the third pushback, then the fourth one, and when I import the second and the first, nothing happened. So that's why it's very important to import the surface in order. All right. You can also go to report and calculate the reserves from each pushback. I'm not gonna do this, but it is also possible. Okay. I also made a spreadsheet here called factors, because as we're gonna do the ramp up, I set how many rock and ore we're gonna need through these years. So the first year, this amount of ore, this amount of rock. And the second year, when 3/4 require this amount of rock and this amount of ore. I also create this minimum and maximum rock and minimum and maximum ore. As you can see, you just picking this number and the range is 20%. So here 20% less, 20% more. Okay, based on this number. This number came here, the number that I set. So everything is linked. So I recommend as well, because it will be better to copy and paste in our sequence parameters. All right. So let's use, I'm in the webinar final, webinar 3, okay, the last webinar. I can go here in the scheduler section and pushback file. Here I need to import the pushback files. Okay, that's why I put all the surface in one file, because here will be needed. Click OK, and now settings. So here is very interesting, those tabs. The first tab calls time, and this tab is how, without the software, how long is a year, because NPV doesn't know counting by days, but he know counting by tons. So as it is, this is the default, okay? As it is, NPV is considered 1 million ton of ore 1 year. So every time that it's achieved this number, it's gonna change the period, it's gonna change the year. So this we call as hard constraint. So the software will do everything that it can to achieve this value and stay in this value. Okay? In our case, our R is not 1 million is 1.2, so we can click in R, edit, and change to 1.2, right? Here below we set our ramp up. Okay, so by the end of 200 years, the factor is 1. So I can type, but I can also copy from my spreadsheet. Now, by the end of the first year, I want this factor. By the end of the second year, between 1 and 2, the first and second year, I want this factor, and the rest, I want this factor. Okay, so let's move to targets. Okay, here is our we constrain the pushbacks, right? So the NPV creates already this strip target. You can click in edit to see what it does. So the name stripped is our ratio, and in the numerator column there is rock and R, so rock minus R, and the denominator R. Okay, this way is a little confusing. You can click in display to see how is the formula. Okay, and here we set also our targets per period. Okay, that's why again I made this spreadsheet. Will be very helpful. In our case, we are not using strip ratio. We're gonna add a new one. We're gonna call rock. Okay, rock target. Let's use different name from the ones that already exist in the block model. So our rock target is rock, is a rate per year. Okay, and my constraint per period, let me copy here. No, this period. Target what I want. It's rock. And the minimum and the maximum that I allow as well. Click OK. Right here, pushback constraints is the part that I can, as the name says, constrain my pushback. So I can tell which pushback the maximum sync rate. So how many benches each pushback can be mined by period, or how many tons I want to be mined in each pushback by period, or even constrain and tell the software to start mining the second pushback after some period. Okay, allow it. And instead of, if we're gonna use the same value for all of them, we can use this instead of typing 6, for instance, for all of these fields. We just click here, 6, and set to, and will be filled. To set to all rates and all tons will be filled this column. Okay, again, we are not fill yet here, because it's good to have a first impression of how NPV does things. So here is very interesting because the software doesn't mine every block, doesn't sequence every block. It groups the blocks in activity. So activity is a collection of consecutive OES blocks. Okay, and in these tabs we can define its size, okay, their size. So there's a lot of details here. I'm not gonna through all of them, but the first one here and this one, the search extend, are important. So maximum rock mass in activities is how many rocks, how many tons will be in each activity. And the software, the formula is the total rock divided by 50 times this number. So we make a division and gets a number of activities. And with this number, and pick the total rock divided by this number, we have the total number of activities. All right. Again, this is a lot of formulas. I'm not gonna deeper than this. So the software counts how many activities it generates, and our developers should suggest that we keep around 300 activities. Okay, for our first time, we don't need to change this, but in the next we're gonna achieve, because these two only gonna generate 100 activities. Here in search extend, we give more time to the software finds the solutions. Okay, so again, these numbers, bigger this number, more options, more activities we create, more options the studio has to achieve our constraints and targets. So, but it charge time and processment. So for our example, things will be quick, but bigger data, bigger bits probably will take some hours. Okay, so we need to be careful with this. And the last tab is about pushback dependencies. Okay, I can show sequence. Here, the software is linked each pushback. Okay, one with 2, one with 3, one with 4, 2 with 4. Okay, and of course, the software is not allowed to mine for example, the fourth pushback before the third one. Okay, they can be at the same level, but never, the fourth never be lower than the third one. So we can constrain some banks. So for instance, the number 2, here I'm telling the software only start to mine a bench in pitch 2 if I already mine 2 benches in pitch 1. Or I can only, on the example is the same, I can only mine 1 bench from pitch 3 if I already mine at least 2 benches from pitch 2. So on. Again, it's not recommended to play with this at the first time. If you let like -1, we let the software decides, the algorithm decides how many benches we're gonna mine. Okay, so now you can press OK and run to see our results. All right, so here we can see that in this column we can see that the software follow exactly or very, very close to what I want it to do. Okay, but as a consequence, the rock is not that constant. So you can see 4, 7, 11, 10, 11, 10, and so on. So now let's see what the software can give us as well. Let's go to report and see shadow by bench. Okay, here in this report, we can see how many benches was mined by year and by pushback. Okay, so here we can analyze if any bench was mined like any pushback was mined like 8 benches in 1 year, or 10 benches or 12 benches. So everyone has a number, a limit for how many benches be mined by year by pushback, right? Here, so we can see this report. We can visualize the result as well. Click OK. Okay, here we are. So here we already see the first thing is some activities in the fourth pushback. So we see something's wrong already. Okay, we need to change, to fix this. I will teach you as well. So here some people like to use the legs option, bench below last. It will show you which activity comes after this period. Okay, so it's up to you. I like to use below topo, and then we see the progress. Okay, we can do some more analysis in Excel. So let's click in data, export model. I already taught you how to export this model in the other webinar. So click here and follow the procedure. Generate this one. It will generate this table. Okay, and we click here in File, Save as CSV. And we can create some pivot table based on this CSV file. Okay, so here I create 2 pivot tables. The first one is the pushbacks by period by Z direction, all right, by bench. So here I generate this graph that show me from which pushback is coming the tons of each year. Okay, so as we can see, as we saw in the visualization, there is a part of year 1 that comes from pushback 4, and that I don't wanna. Even in year 2, I have something from pushback 3. Okay, so it's nice. I also create this kind of filter. I can filter here, but I can also filter here. Just see only pushback 1. I'll deals in by bench. Okay, let me just put in order. Okay, so this how pushback 1 be mined. So just things that we can do. All right. Okay, so now we need to repair some things, put some more constraints. Let's go back to NPV in optimization. Okay, so for us to compare, what we can do is just create a new shadow scenario. So case study, add, can call schedule 2, and just copy and settings paste. Okay, click it twice And here in settings, we can see that the same thing apply. So here my first thought is to fix those pushbacks, okay? Constrain when we're going to start mine pushback 4 and 3. Okay, so we can put the numbers here. I already did that, okay? Is this part. So my first schedule here is the same. Let me change the report. This schedule here is the same as we created, okay? My second one now is the one that are constrained by bench, and change my activity, okay? All right, I forgot, but when I generate the first schedule, gives me this information here. So how many seconds it takes to create each line here. What interests us is the first one, generate activities. It generates 150 activities. As I told you, the optimal number is 300, so we need to increase this. I found the 6 here to make 300 activities. We will see, all right? And all those other informations is some details that can be changed by changing these numbers as well, okay? But I'm not gonna do this. So everything, as I said, is equal, less this 2 number was add, and this 6. So we can run it again. Okay, so we can see the OR remains the same, but some changes was made here. We can see also the NPV to compare. So our NPV increases, so this scenario is better. We can visualize to see. So here now there's no fourth pushback by the first year, okay? Okay. And not even the third one as well, because here it's only I set that is only allowed to start pushback 3 after the third period, and that's exactly what it does. Here period 3 there's nothing, period 4 start pushback 3, okay, and after period 5 start pushback 4, okay. I need some improvement to do, because let me show you this constraint what it does. So here it generates 1, 2, 3, 4, 5, 6, 7 bench in 1 year for one pushback, and for me this is a lot. For my mind, I want to constrain that to at least 6, so I can do this, okay? And I did. In my third schedule, I can go to settings. In targets, I constrain. First, I constrain only the fourth pushback, but then after the third one was there was more than 6 pushbacks of 6 bench as well, so that's why I constrain both, but the rest continues the same, Okay, to not waste more time, I just need to go to report, schedule to show you the final result. Okay, as you can see, again, keeps the same, and here changes a little bit from the previous one. So here that we are allowed to 9 million, and sometimes we are mining 11 million tons. So this is what the decision we must make, because also it's valid to make a hard constraint in rock, not only in ore. I did that at first, so I constrain my rock as almost 9 million, but the ore looks how it goes, like it's floating a lot, and it's not good at all. Okay, even if I stockpile some periods here, won't be enough to supply all the other years. And you see, by the end, we have a lot of almost 2.5 million. Okay, so but I can improve this. I already did, and this was my best result. Okay, so all of them almost near to 1 million, some more, some less. And I could constrain and keep and increase from 9 to 10 million rock tons. So now this is the decision we must make. If we had equipment to remove 11 million tons in this period, but keeping our rate constant, or if I cannot hire more equipment to make 11 million tons, I need to do something with my plant, reduce the size, for instance. So as this is just an example, okay, it's not real. I have money to hire more equipment, more loader, more trucks, to at least these 6 years, I can work around 111 million tons. So again, it's up to you which scenario you choose. Okay, and I will export and generate an Excel spreadsheet the same way. Let me this one. And this is what I get. Okay, for me this result is good. I don't know you guys, so it's up to each one. We can make some changes, try something more, but for me it's enough. All right, so the next step is just with the file that I exported, just drag to Studio OP, and 2 weeks from now, Terence will continue the webinar campaign. And that's it. Thank you, everyone.